Hello, today I'm going to show you how to calculate the integral of sine ln x dx. Okay, so this integral you can solve by a combination of the substitution rule and the formula for the integration by part. Okay, so here if I define ln x as t, and if you take the derivative from each side of this equation, the x over x will be equal to dt. In other words, dx will be equal to x times dt. Okay, from this definition you can conclude that x is actually equal to e with the power of t. Okay, in other words, here dx will be equal to, instead of x I write e with the power of t times dt. Okay, so now if I substitute these equations into this integral will be equal to sine, instead of ln x I write t, and instead of dx I write e with the power of t times dt. Okay, so now the question is actually how to calculate this integral. So this integral you can calculate it using the formula for integration by part. That is, the integral of u dv is equal to uv minus integral of v du. Okay, so here if I define sine t as u, you can conclude that cosine t dt is equal to du. If you take the derivative from each side of this equation, you get this one. Okay, and then let's define et dt as dv. Therefore v will be equal to integral of et dt, which will be et, e with the power of t. Okay, so now if you substitute this expression into this formula, this integral will be equal to uv, that is u, this is v, that will be therefore e with the power of t times sine t, that is uv, minus integral of v, that is et, times du, and du is equal to cosine t dt. Okay, so now the question is how to calculate this integral. Okay, so this integral, you can calculate this integral using the basically formula for integration by part. In other words, you need to apply this formula one more time. So therefore, so now we have to calculate the integral of e with the power of t times cosine t dt. Okay, so here I basically define cosine t here as u, and if you take the derivative from each side of this equation, minus sine t dt will be equal to du. Okay, and if you define et dt as dv, therefore v will be equal to integral of et dt, which will be et. Okay, so now if you substitute this expression into this formula for integration by part, that will be equal to uv, and u is this one, v is this one, so this integral will be equal to uv, that is et times cosine t minus v minus integral of v du. So v is here e with the power of t times du. Du is minus sine t dt. So this minus by this minus will be plus sine t dt. Okay, so this is the integral basically of this term. So now if you look at the original integral, is this one. We wanted to calculate this integral. This integral is equal to basically this term minus the integral of this term. So now we calculated the integral of this term, which is this one. So now if we substitute this solution here, you will get, therefore here, the integral of et sine t dt, basically this term, okay, this integral is equal to the first term, which is equal to et sine t, minus the integral of the second term, and this integral is equal to these two terms we already calculated. So that will be minus et cosine t minus integral of et sine t dt. Okay, so now you see here these two integrals are the same, so all you need to do is to bring this term to the other side of this basically equality. So and if you do that, what you will get, that will be equal to 2 integral of et sine t dt, because this one plus this one, that will be 2, will be equal to et, I factor it, sine t minus cosine t. In other words, the integral of et sine t dt will be equal to 1 divided by 2 e with the power of t sine t minus cosine t. Okay, and so that's the solution to this integral. So here all you need to do is to substitute this parameter u, this parameter t, by the definition of the t, and that at the very beginning we define t as ln x. Okay, so wherever here you see t, basically you need to write ln x. So in other words, the integral of sine ln x dx will be equal to 1 divided by 2 e with the power of, instead of t I write ln x, times sine ln x minus cosine ln x. Okay, and you can rewrite it again, because e with the power of ln x is basically x times sine ln x minus cosine ln x, and plus c, which is the constant of the integral. Okay, and that's the solution to our integral. I hope you found this video helpful. Please feel free to subscribe to this channel if you are interested, so that you get updated when I upload new videos. Thank you.